Hi friends, welcome to my channel. Let's have a look at combination sum again. So this time problem 216, combination sum 3. So here we're going to practice the backtracking technique again. So this problem asks the following. So find all valid combinations of key numbers, in other words length is key, that sum up to n such that the following conditions are true. So we can only use the digits 1, 2, up to 9. And each number is used at most once. In other words, either use or not. So we are required to return a list of all possible valid combinations. The list must not contain the same combination twice, and the combinations may be returned in any order. So that's the main statement. The additional constraint is on the range of k and n specified here. So in example 1, for example, so we want to have a length 3 combination which has with sum 7. So here we return 1, 2, 4, right? So you can analyze similarly example 2 and example 3. So in example 3, so k is 4 and n equals 1. So in this case, nothing returned, or returned an empty array or list. So with that said, let's look at the method. So the method is again backtracking. So some people may call it traversal. So the idea is actually very simple. We thought of using brute force to build the valid combinations. So in between, if we find some paths are not valid, we're going to revert back. So that's the backtracking, or the words backtracking. So if we compare this problem with Leetcode problem 40, so what's the difference and what's the additional requirement? The difference is that first, in this problem, the list is more specific. The list is nothing but 1, 2, up to 9. So another thing is that we have one more requirement here. So that is the length of the combination shall be key. So actually it's good to compare the solution format here with those for Leetcode 40 and 39 in the channel for two things. First is to compare the difference in problem statements or requirements. Second, compare the coding formats, especially the subtle details. So with that said, let's look at the code. So this code in some sense is self-speaking. So we are going to explain every line, and we are going to split into several parts. The first part is a preparation. So we are going to initialize this one. So it's not necessary, but we want to make a connection with Leetcode 90 and 39. So we're going to use this list range from 1 to 10. So this is a length array of length 9, right? 10 minus 1 is 9. So and this is done. So we're going to initialize a variable called answer. So this answer is a container which is going to hold all the valid combinations we built. So that's about it. So next we're going to do backtracking. For this, I'm going to define a function. I'll call it f. So we can think this f as a backtracking function, or DFS, or just a worker. This worker will build the valid combinations for us. Once this worker finds or builds a valid combination, it will automatically update the answer variable. Or we can think of this worker put the valid combination into this answer container. So with that said, let's do this. So it accepts three variables. First is the index, and the second is the current sum, and the last is the path. So first we're going to have some stop conditions. For example, this if current sum is larger than the target, right? So in this case we're going to stop, so corresponding to a return here. Another case is that if current sum equals target, so this is a potential candidate. We need to also check the length. So if length of the path equals k, right? So in this case, we're going to append this valid path to the answer. So we're going to append a copy of this path because we're going to maintain this path state and do the following steps. So this is the one, and also we need to return, right? So this, you can understand this returns as stop condition. So right. So if this two case is done, then we're going to consider the generic case. Before we do that, actually, because there's two conditions involved. One is a sum requirement, one is a length requirement. We consider another stop condition. That is, if length of the path is greater than k, so we should stop. Or if I equals length of nums, that is none actually. So let's put this as length of nums so that we know this actually is for a generic case. So if this is the case, we're going to return. So these three returns are three stop conditions, and the one between if, the middle if actually did something, it updates the answer container. So with that said, let's do the genuine work. So if we do not stop, in other words, we do not enter the three ifs, then we're going to determine if we use the current number or not, right? So if we use the current number, we're going to append the current number called nums I, right, to the path, and then we continue our traversal to next index. So that is f. Oh, sorry. Let's right here. So after we do this, let's do the traversal I plus 1, and then the current sum actually is incremented by nums I. The reason is that we are using this nums I. So we are going to pass the path status. So this actually corresponding to the case that we choose to use nums I. So if we do not want to use this I, so actually we need, so do not use nums I. What should we do? We are going to update the path state. So we're going to pop this, and then what we're going to do is f I plus 1. We look at from the next number, and then we do not update the current sum because we do not use nums I, and then the path state. So that's it. That's the thing for we want the worker or f or backtracking function do. So next we are going to prepare our return. So this corresponding to call this function, let's call f0, and initially the sum is 0 and the path is empty, right? So once we finish this, we're ready to return the answer. So that's actually a full solution format for this problem. I would say this problem is very special if we have first practiced Leetcode 40 and 93, because the list is specified just with an additional check for the length of the combination. So with that said, let's look at the test case. Yeah, it passes example 1. Now let's look at a generic case. Yeah, it passes all the generic cases. So I guess that's it for this specific solution format. So you are welcome to watch other related problems in my video. Thank you so much.